Hi everyone. In our last discussion, we talked about, had an introduction to the fundamentals of geophysics, and today I want to talk about what criteria do you consider in the choice of the geophysical survey to use in the field. So things we have to put into consideration, one of them is we have to look at the physical properties of interest. So if I'm looking at the rock density, if I'm looking at permittivity, if I'm looking at the wave velocity, those properties are going to influence which survey I'm going to consider as opposed to the other. So which method responds to the physical properties of interest? Which method can provide the required level of detection and resolution for the subsurface features of interest? Here you find that sometimes if I'm going to I want to get information about maybe my target of interest is maybe a kilometer down, I may not be used to use gravity survey method because it can't give me it can't differentiate the target, or I can't get enough information about the target that is a kilometer away. So which methods can perform well for the given project site conditions? Here I put in the here we have a consideration of the terrain. Sometimes you find that some areas could be mountainous, there could be high rock, there could be even offshore. So in that case, you look at the possibility of using the surface geophysical surveys may not be the best option. So you may think of going airborne, and not all methods can be carried out using the airborne geophysical survey. Which methods provide complementary information to help improve interpretations? Usually we find that we rarely use the same, or we rarely use one geophysical survey method to draw conclusion. So as we are choosing, we have to look for methods so that we choose like 2 or 3 methods which are going to complement each other. Maybe you find that maybe the density and elastic velocity, they are related. Maybe resistivity is also related. So in that case, that's when I can carry out gravity, I carry out seismics, I carry out resistivity, so that the results I get, each of those results, each of those interpretations is going to be complementing one of the methods that I'm being used or that I'm using. So what direct observations are performed? So it's always very important. If I'm going to have the are they reflections from the ground, or they're going to be just physical cores from the boreholes which have been drilled. So all that information is very important. Which methods are most cost effective and overall, because the most overall or the underlying principle of carrying out these geophysical surveys is to make a profit. So you have to look at quality vis-a-vis the cost, because we wouldn't want to carry out a high quality geophysical survey and at the end of the day the company is going to wind up. And again, you wouldn't want to get maybe given a lot of resources, and then you find the company is considering a very cheap method. So the two have to go hand in hand. What other data is required to interpret and constrain the interpretation of required geophysical data? So the expected results is very important to put into consideration, and the likely limitations, because these ones are done during the survey planning, which we saw in our previous lecture. So we will make the decisions of the methods to be used, the plan of the survey, so measurements, data analysis, data interpretation. Why? Because if you don't have maybe personnel who can handle the seismic survey, then you wouldn't be in position to go in for seismic survey because it would be hard for you to perform it. If you don't have people who have ever, experts who have ever performed electrical resistive tomography, then you don't have to go in for that. If you go in for that, be ready that you have to look for those personnel, and maybe you have to hire them. So all that has to be put into consideration. And lastly, will the overall program likely to be technically successful and cost effective? That has to be done. You work along with the petroleum economists, reservoir engineers, drilling engineers, and other team of experts to see the underlying principle of carrying out that survey or the surveys vis-a-vis the cost. If the reservoir is successful, so you have to have a trade-off between the input, the capital inflows, and probably the revenues that will be accrued from the project. So when you are going to choose a geophysical survey, the number of things you have to look at. One, you have to look at the geophysical specifications. These ones include the survey objectives. What is your intended survey of carrying out the geophysical survey? Then site-specific constraints. Look at the terrain. Look at the maybe population density, because also is very important. Look at whether it's ecologically sensitive area, if it's around the site, and all that from the environmental management authorities. Look at the survey logistics that you currently have. If you don't have, where are you going to get these logistics from? Are you going to hire? Yes. At what cost? And from where and from who? And are they available at the time you need them? All that information is necessary. Then the budget. So this one will specify or influence which kind of survey you are going to perform. So if the budget is large enough, then you have a wide range of options to draw a conclusion from. If you are working on a tight budget, then it is very hard to think a lot. Your options are constrained. The survey design. So if I'm going to carry out maybe a seismic survey, is it a 2D, is it a 3D, or is it a 4D? So all that one has to come in. What's going to be the length of these lines that I'm going to perform? So are they short, are they long? So all that information has to come in. The geometry and the depth. So we have to look at what depth of investigation are we looking at, because that will influence which survey and which equipment we are going to use. More so if you are going to use the active geophysical survey methods, where the source has to be having characteristics which can be in position to reach the target of interest. New technology has to be put into consideration. And then if you are looking at the geophysical method, you have to look at which physical property is being considered or is focused, which geophysical equipment are currently available. So are you going to be considering old technology or new technology, or is a combination of the two? If you have two equipment, I have to have a trade-off cost vis-a-vis intended the quality of the results that I want to obtain. The station interval and spacing. So what should be the offset? So that information is very important, because the shorter the station interval and spacing, then the more time you are going to spend. It means that the higher the cost that the project has to incur. So the line length, how long the line is going to be, how many lines you are going to have, and what is going to be the orientation. So that's also very important. So which kind of data is required and at what resolution, that will influence the sources and maybe the recording equipment you're going to use. Then the data acquisition and analysis also influences which geophysical survey you're going to choose. So which data are you going to acquire, how are you going to process data, and what interpretations and conclusions that have to be drawn about that survey method. And lastly, the data and information for submission. What information or what data is required by the client? So if you look at the data which is required by the client, it helps to work backwards and know which survey methods can help you to achieve that kind of data that is required. Usually when the geophysical surveys are being carried out, there are some constraints, there are some limitations, there are some shortfalls. These have been categorized into 5 major key areas. One of them is a financial constraint. So how much money is available for the project? Because you can't go beyond what is available. So you have to work within the budget which is given to the company. Logistics, which logistics are available? Do you have them at your disposal? Are you going to buy them? Are you going to hire? So sometimes the question of hiring or acquiring comes in. But if you're going to purchase these, if you're having a project for a full year, I don't think you may need to hire these logistics. You may need to buy this equipment. If you're going to have a project for 3 weeks, I don't think you need to buy. You need to hire. Unless you have a number of projects that you're going to be carrying out simultaneously. So that's when you can hire. So the logistics comes in. So the social constraint. Usually in areas where these geophysical surveys are located, they are remote areas where the social settings is different. In some areas, people reject these projects. They have reservations. They have their inclinations culturally. So some of them you hear telling you, when they perform this geophysical survey here, our animals stopped breeding, our animals stopped producing. So you realize that social constraint comes in, and it's also very important. The political constraint. So this political climate, some areas are most of the times they're hard to reach. We find that if there are some political instability, as sometimes you hear that these geoscientists, you hear that these technicians, experts have been kidnapped and they want a ransom. So in that kind of area, you may not be in position to carry out the survey. Sometimes it can be government change. So when the government changes, you have signed contracts with the previous government. They may tell you no, all those contracts are null and void. So it will be a challenge. So religious constraint. Different religions have different beliefs. Others don't believe that women can work. But in the survey methods, we believe, or in our surveys, we always believe that all are human beings, all are equal. So the work which is done by the man has to be done by the woman. Some religions have special days of worship. They say maybe a Friday for us we can't work. Maybe a Saturday for us we don't work. A Sunday we don't work. So if it is a special day like a Christmas, like Easter, like Eid, we don't work. So now things like that, they can influence the survey, your geophysical survey that you're going to carry out. Usually when we are acquiring data, there are different scales which are to be considered, but for different purposes. Sometimes, usually when you're doing reconnaissances, we can consider the regional scale. So where being detailed is not very much our interest, we want to know, do we have some leads in a given area? This could be square kilometers, maybe 100 by 100. So once we get some leads about that region, we can go to the local scale. And in the local scale, now we are narrowing down. If you had 100 square kilometers, now once we have run maybe the airborne survey, now we say maybe let us go now to the surface survey, and maybe we try to investigate the maybe 1 square kilometer from the 100 that we had. And once we have also got enough information on the local scale, that's when you can go into that detailed site data scale. So here we can get maybe some cores, we can do the drilling and get some core so that we are exact. We are not just assuming, but now we are exact about what we are dealing with. That's when we can go into the subsurface geophysical surveys. And lastly, we can talk about the core sample scale. That's the small scale we can deal with, and this can be at the laboratory level, unless maybe you're going to cut, you're going to get thin sections to be in portion to be analyzed in the microscopes. We find that we have to note that regardless of the area of interest, work should progress from the regional to local setting to site-specific and then to the last area, which is the core scale. So all these ones have to be undergone, because by the time you come to the core sample scale, it means that the equipment you're using are high-tech and they're very expensive as compared to the regional setting where you can just run airborne within a few minutes and then you have that information. But when you start with the core scale, it may be hard. You keep on getting cores and you find that by the time you finish the 100 square kilometer area, it's going to be very expensive. But if you run airborne, you can be in a position, just from regional scale, you can be in a position to get some leads. You go on concentrating on some key areas of interest. When you are carrying out the geophysical surveys, we basically have three major steps. One of them is the data acquisition, where we have to go in the field and collect that data from the area of interest with the help of this geophysical equipment. So other equipment may not be directly for recording the data, but they may give you enough information to supplement the data you're getting, like the GPSs. So it's not going to be to acquire seismic data, but as you're acquiring the seismic data, you need those locations. After you acquire the data, of course, you put aside the quality data condition, quality control, and so on. You have to do data processing. So where you have to refine the collected data, you do filtering, you do enhancements, and so that the data is good for the third stage or the third step of the geophysical survey. If anything goes wrong in the data processing, we don't expect the interpretation to be good. And the third step is data interpretation. In here, we are analyzing and interpreting the processed data so that we can come up with an informed conclusion about what our objective of the survey was, whether we have attained our objectives or we have not attained the survey objectives. So this is very important. Hello colleagues, with that, let us stop here. In our next lecture, we shall try to talk about the seismic. We shall talk about the geophysical survey sources and receivers. Thank you for listening.